here. One with square root and one with cube root. Let's go over the square root together first. It's 72 over 3. I cannot do anything with the 3, so I'm just going to keep the 3. But 72, I can divide it by 36, which is a perfect square, and I get 2. So if I want to rewrite the radicand, I write it as 36 times 2. And then I'm going to, in the next step, I'm going to break down the radicals. So I have radical 36 times radical 2 over 3. And then if I, 36 is a perfect square, so if I simplify it, I get 6 rad 2 over 3. And then I know that 6 goes to 3 2 times, so I just have 2 rad 2. So this is for that. And then let's go over the cube root together first. I can, by the properties that I showed you, I can break down this radical to 2 separate radicals. So I have cube root of 5 over cube root of 27. And I know that cube root of 27 is a perfect cube, so I can write it as just 3 and cube root of 5. And cube root of 5, I can't simplify it anymore. So this is how we simplify more complex expression. Alright, let's simplify some radicals that have variables in them. Generally, we can say that when we have square root of something squared, that number comes out. But this is only when the number is positive, when the radicand is positive. And when we have a cube root of something that is cubed, that number again comes out of the radical. But this is for any value of a. It can be positive or negative. So let's try this example here. This is square root of 8a cubed. So I know that 8 goes to 4 2 times. 4 is a perfect square, so I'm going to write it as 4 times 2. And then for a, I'm going to write it as 8 times 8 times 8. But this is, I'm just doing it to show you how to do this. You don't have to do it every time. I know that for this is a square root, so square root of 4 is just 2, so I'm going to write it out of the radical. And then for this part, for any repetition of 2's, 1 pops out of the radical, 1 pops out of the square root. So for these two, I'm going to write 1a outside. And then in the radical, I have this 2 and this a. So that's just 2a rad 2a. The next example is again a square root, but it's 2 times the square root. So whatever leaves the radical gets multiplied by these 2. So I'm going to keep the 2 for now, and then instead of 75, I'm going to write 25 times 3, because 25 is the largest perfect square that I can divide 75 by. And then times 3. And then for x to the 5th, I can write it like this. X times x to the 4th. 25, square root of 25 is a perfect square, so 5 comes out of the radical, so that would be 2 times 5. And then for x to the 4th, for every two x's, 1 pops out of the radical. So in x to the 4th, I have 4 x's, so 2 x's pops out of the radical, so that will be x squared. And then in the radical, I have 3 times x. And then 2 times 5 is just 10. So 10x squared rad 3x. And then for the third one, it's a cube root of 3x to the 6th y cubed. We can write it like this. X times x times x. Again, I'm just doing this to show you how you can simplify this. You don't have to write it like this every time. So for every 3x, 1 pops out of the radical, and for every 3y, 1 pops out of the radical. So for these 3, I have 1x here. For these 3, I have another these three, I have just one y, and then cube root of 3. Okay, I have two more examples for you with variables. Let's go over them together. The first one is cube root of 27a squared b to the 6th and over 9 square root of b squared. So I'm going to break down this radical to 3 separate radicals. So that would be cube root of 27 times cube root of a squared times cube root of b to the 6th. And then this is 9 cube root square root of b squared. Now let's simplify them. 27 is a perfect square, so just 3 comes out of the radical. This one does not simplify, but this one is b to the 6th. For every repetition of 3's, 1 pops out of the radical. So I have 6 here, so b squared pops out of the radical. And then here I have square root of a squared. And here I have 9. Square root of b squared is just b. And notice that we're simplifying all of these radicals assuming all the variables are positive. And then we can cancel out some numbers from denominator and numerator. So 3 and 9, I get 3 in the denominator and I get a b here. So I have b cube root of a squared over 3 here. So this is for this example. And then for the second example, it's square root of 8 x to the 7th y squared. Why don't you give it a shot and then we go over it together. Alright, for 8, I know that it's divisible by 4, and I get 2 if I divide by 4. So that would be 4 times 2. 4 is a perfect square. And then times x to the 6th times x times y squared. And then the things that comes out of the radical is this 4. For this 4 I get 2. For this x to the 6th I get x cubed, and for this one I get just y. And then this 2 and this x are all in the radical. So this is it for this example. So that's it for simplifying radicals. Thank you for watching this video.